Hi everyone, it's Dr. Bianchi and I am demoing the last version of the t-test that we will cover in our course, which is known as the repeated measures t-test. So if you haven't already flipped to the next page of the formula sheet for the t-test, go ahead and do so. All of the formulas for the repeated measures or related samples t-test, those terms are interchangeable, are found on one page. Now, a repeated measures design is where we study the same group of people twice. So we still have two sets of data, but the data is coming from the same people. Typically, these are what we call pre and post studies, where we measure people at one point in time, and then we come back later and measure them again. Whenever you have one sample that's been measured twice, you're going to be using the repeated measures t-test, because that version of the test looks to see if people changed over time. Did they get different on some kind of outcome variable? So here's an example here in theme with Thanksgiving coming up. A researcher would like to examine how the chemical tryptophan contained in foods like turkey can affect mental alertness. A sample of 9 college students is obtained, and each student's performance on a video game is measured before and after eating Thanksgiving dinner, including turkey. I don't know about you, but after a Thanksgiving meal, I am pretty much mentally shot. I think that's pretty common for most people, usually makes you pretty tired. So the hypothesis here is that performance on this video game is going to change. The data show the average score dropped by 14 points after eating the meal, and the standard deviation of these data is equal to 12. Now note, you can always calculate the standard deviation or the variance if you're provided with sum of squares information and sample size, but in this case, I've given that info to you. Is there a significant difference in performance before eating versus after eating? Use a two-tailed test with an alpha level of 0.05 and then compute R squared to measure effect size. I'm going to actually show you Cohen's d and R squared for this example. Let's go ahead and see what's going on here. Again, I recommend you take a shot at this question first before watching my solution. We just know that's a more effective learning strategy. So feel free to pause the video and go through the math here and then resume it where I'll be walking through my solution. Okay, I am going to go ahead and switch over my camera and show you the solution that I've come up with here. Okay, so repeated measures t-test. The first step, again, is to calculate an error term. Notice how every single version of these t-tests has some kind of error term in the denominator. Here we're looking at the error associated with the mean difference. In this sample, there was a 14-point deduction in performance, but samples vary. Okay, so the estimated error associated with that mean difference can be calculated. We're using the sample to do that. Okay, the formula for doing that, let's get this straightened out, is simply twofold. You can use the standard deviation based approach, okay, standard deviation over sample size, okay, square rooted, or the variance based formula, move this out of the way, where we square root the variance over the sample size. Use whichever one is easier. In this example, the standard deviation was given, so why not just use this one? Okay, we're going to go ahead, just make this a little bit bigger. We're going to plug in our standard deviation of 12 over the square root of the sample size, which is 9. We end up with 12 over 3, which is 4. Our estimated error in this example is 4. Here's our formula for the repeated measures t-test. Up top is just the mean difference minus what the null predicts the difference would be. By definition, the null says there's no difference, right? Nothing happening, nothing going on. People aren't going to change pre and post Thanksgiving dinner. This is a 0. So really up top, all you need is the mean difference of 14 over the error. We just got the error of 4. That's going to go right down here. Okay, here's the math. T is equal to 14 over 4, and we get 3.5. Our T obtained, 3.5. Okay, just plug and play. Now, like usual, we consult our table. In this situation, T critical is associated with 8 degrees of freedom, right? 9 subjects minus 1. If you use the table, you'll see the critical value is positive and negative 2.306. We got a 3.5. We're going to reject the null. Our t-value is so big that we can be confident that eating turkey significantly impacted video game performance in this example. Let's look at measures of effect size. Okay. How do I calculate Cohen's d? Super simple. Up top is the absolute difference of, is the mean difference, divided by standard deviation. There's a 14-point difference. The standard deviation is 12. 14 over 12 is equal to 1.17. Huge Cohen's d value. Okay, eating Thanksgiving dinner changed performance on the video game by over a full standard deviation. Very large effect size. What about r squared? Okay, calculating r squared is the same for all the t-tests. It's t squared over t squared plus the degrees of freedom. We had a 3.5 for t, we square it, over 3.5 squared plus 8. Okay, we throw that into the calculator. We end up getting an r squared value of 0.605 or 60.5%, meaning that 60.5% of that 14-point reduction in scores can be attributed to the turkey dinner, the tryptophan. The other 40% about other factors, things we weren't looking at. How would we write this up in APA format? Let's go ahead and do an example here. We ran a t-test, make that darker. Okay, with, camera's getting all out of focus here. 8 degrees of freedom, it was equal to 3.50. I'll zoom out of this once I'm done writing. A lot of multitasking here, filming this and everything. Our probability of an error is less than 5%. D equals 1.167. R squared equals 0.605. Okay, a t with 8 degrees of freedom equals 3.5. Probability of an error by definition is less than 5% because we rejected the null. D is 1.167 or 1.17 if you round it, either works. R squared 0.605. That's your APA string that would go in a research report. Okay, well, hopefully that helped you walk through the problem. If you are confused, stuck on any aspect, please post to the discussion board or reach out to me. Check your math, make sure you're using the right formulas and plugging things into the calculator accurately. That is the demo of the repeated measures t-test, okay? Any questions, please let me know. And I'm going to end this video.